So both in a couple earlier talks, both in this session and earlier days, we've heard a lot about foot placement. I realized my title didn't make this clear, but what I'm going to be talking about is entirely human and entirely experimental. So a little bit different from what I might have seen earlier. Just to get this out of the way, I forgot to put my conclusions up so you can get an idea of where I'm trying to go. So the first conclusion is that people do use their gluteus medius, their hip abductor, to control where their foot comes down mediolaterally. Okay? So I think that's the first thing that does matter. And secondly, I think they decide whether or not they're going to activate their abductors based on what's going on in the stance leg and the torso. So specifically the mediolateral distance from where their foot is to where their center of mass with their midline is. Okay, so how I got there. First thing we notice is that sometimes the gluteus medius is active during the swing phase. And if you look at this black line there, that's the average of a whole bunch of strides for a single subject. And that might be something you would see in a textbook. So about the first 2/3 of the stance phase, going from left to right, it's pretty strongly active. And then for the rest of the gait phase, it doesn't look like there's a whole lot going on. So it's commonly thought gluteus medius abductors are active during stance. They don't matter during swing. But if you look at this first half of the swing phase, in some strides there are these bursts of muscle activity. And so what we thought is that maybe we'll start looking at what's going on in there. So this is sort of one extreme of behavior you might see. And this is a different individual where it's a little more apparent that there is a clear burst of muscle activity at that point in the gait cycle. So the way we interpreted this first is that if there's a muscle activity, then that's a sign or an indicator of some type of active control. But it's possible that we're wrong. It's possible that that's not actually what's happening, and that's just noise. We know there's noise when people activate their muscles. So we wanted to see if anything happens, if there's a functional effect of this muscle activity. So there are a couple ways we analyze this. One of them, which is shown here, it's a little easier to see visually, just dividing into what we call loud strides, where there clearly is activity in this phase, and then quiet strides, where there's pretty much nothing going on. So we divide the strides up, and then we saw if that had any effect on where the feet went. So shown here is the left foot, sort of in the middle of the screen, the right foot back here, so we matched it so they started in the same position, they had the same velocity, same acceleration, and then we saw if anything changed during the course of that step. And so, unfortunately here, when we tried to draw things to scale, there's a lot more going on anterior and posterior, so it makes the effects mediolaterally not look that big. But there's a clear effect that gradually you get this more lateral movement of the foot when the gluteus medius is active. And we saw this in every subject in which we did this test. There was a significant effect where the abductor is active, you get wider steps. And the way people execute this is with more lateral foot placement. So we define that as where the foot comes down relative to the midline. So it is something that's happening in the swing leg. It's not entirely going on just in the stance leg. Okay, great. So this muscle activity does something. That's good. But we wanted to see when people decided that they should actually use this active control. When would it be a good idea to actually activate this muscle and maybe move the leg a little bit more laterally? So we used a similar strategy, divided up in quiet and loud. And the one thing we saw that was the best predictor of what was going to happen next is where the center of mass was relative to the stance leg. So what's shown here, the blue line is just a trace of the center of mass, and if it's further down, it means it's farther away from the stance foot. So the opposite side. And center of mass position was a really good predictor in all our subjects of whether or not they were going to activate the gluteus medius or not. Center of mass velocity acceleration didn't really tell us much of anything. And there was another effect, which I'm not sure if calling it a predictor is the best way to go, but we saw that if you looked at the opposite side, so the contralateral leg, and we looked at the muscle activity there, during the same time period where we had this difference between quiet and loud strides, the loud strides were also louder on the stance leg. So I think these two things are related, where your center of mass is and how much you have to activate your stance leg. But both of these what we observed sort of suggests, and this isn't an exhaustive list, but suggests possible feedback sources. So maybe people sense where they are in space, so what's going on with their stance hip using muscle spindles or some other way of sensing where you are in space. Decide if I'm far away, if my center of mass is far away from my stance foot, I should activate my gluteus medius on the swing side. Or maybe they're just matching sense of effort. So if you have to try harder on their stance leg, I'm going to go ahead and try harder on my swing leg. So that brings us back to my conclusions. So we do think swing phase abductor activity does something, and we think people decide whether or not they should do it based on what's going on in their stance leg. And since this session is titled something about strategies, I figured I'd better put one up there. So it's very simplified. We're saying when your stance leg is abducted, you should abduct your swing leg.
Before we take some questions, I I have a quick question or clarification. Could you, for those of us that have no ideas about muscles, show which muscle this really is?
Okay, so gluteus medius, yes, it's a hip abductor is its main function. It's right there. Okay, it's the one most on the surface. It has the biggest moment arm for that. And in case anyone was going to ask this, we put our electrode placement as close to directly laterally as they could, not anterior or posterior, because it can do a little bit for flexion and extension, but we always tested to make sure it was most clearly, by far most active when we were doing abduction.
Okay, we have time for questions. Yes, please.
So it's really nice correlation that you show gluteus medius activity and you get a wider foot placement. But the fact that they're both on at the same time, so I'm on one leg, and I sort of fall over and activate that gluteus medius. So a good corrective strategy would be to stick some mass out in the other direction. So how do you know it's not just for counterbalance?
So we know that they both are getting more abducted. It's true that maybe you're just sort of matching on both sides. Now, one problem with this is that the changes were relatively small. So we went back later and we actually then perturbed the subjects, which I didn't have enough time to really get into. So we would physically put their leg more laterally. And what we'd see there, even though then you already have that wide step, is you'd get this huge burst of activity in the gluteus medius on the opposite side. So that then we wouldn't think it would just be you kind of gradually spreading out your legs, but you're actually responding to something, which could be either an internal sort of perturbation or an externally applied perturbation.
Is there a certain moment during the gait cycle at which the center of mass, lateral location, is most important to determining the eventual foot placement?
So we didn't test that. We did it two ways. One, where we looked at it right when the foot came off the ground, and then we looked at it sort of over the entire period when the muscle looked like it was active. The results were the same. So, but we didn't try to test specific points in time when people might be more sensitive to it.
Could the next speaker please come forward? Yeah, Bobby?
Yeah. Did you also look at center of pressure as a possible predictor of the abduction?
So we have that data. We've been using just pure kinematics for now. In part because long term I'm trying to get back to what the actual sensation or what the source of feedback that the humans are using actually are. So that is another possibility, is that they sense how that's moving underneath their stance foot. So we are going to end up looking at that. Right now we think position is important, but I think people can use all sorts of different ways to get back to what they think their relative position is. And we're going to try out the different options.
Andy?
I have two things. One is the exact opposite of that question. It's not sensing the center of pressure, but there are three mechanisms, basically 3 of 6 mechanisms for balance. One is foot placement. One is the ankle torque in the stance leg, which is not sensing it, but controlling it. And then the third one is the one that he was mentioning, upper body angulation control. You don't know if there's any ankle torque, stance ankle torque, correlated with your center of mass.
No, I'm sure people use that strategy. I mean, it seems like if you have the ability to use these different ways of stabilizing stuff, you're going to. It seems like the benefit of the foot placement one is obviously you have a little bit more time, you can make these larger adjustments.
And then if I could just comment on the previous question, is how do you know the leg swing is not doing counterbalance as opposed to foot placement? I think it's just mechanics. It's that you swing your leg, you can move your center of mass a millimeter or something. When you move your foot, you can move the relative location of your foot, center of mass, by the full distance of movement. It's just a matter of control authority.
So this is a little bit, maybe a little bit off topic, but when we were applying perturbations, so we were making people less confident in where their feet were actually going to end up, and they naturally activate their muscle more and put it more laterally. So, and they didn't do that with their stance leg, just the perturbed leg. So the one that they weren't as confident with, they would activate it more and put it more laterally while keeping their stance leg the same. So in that context, they were divided up. So it did look like there was an independent effect based on how confident they were in their control.
Okay, in the interest of time, we have to move on.